In this video, we're going to do self-exercise 4.5 question 1 until question 4. Let's look at question number 1. Find the number of ways in which the letters from the word tular can be arranged if the vowels and the consonants are arranged alternatively. So first of all, we see how many letters are there in tular. So 1, 2, 3, 4, 5. So there are 5 letters, which means 5 spaces. Okay, so see tular. So here we have 3 consonants, 1, 2, 3. So we have 3 consonants and 2 vowels. Okay, so in the next one, we're going to draw 5 spaces, 1, 2, 3, 4, 5, because tular has 5 letters. Okay, so you say that arrange alternatively means that you have to start with C first, consonant first. Why? Because the number of consonants is more than the number of vowels. Okay, so it'll be C, V, C, V, C. Okay, so there are 3 C's, which means that for the first place, there will be 3 ways to arrange the consonant. And then for the third place will be 2 ways because 1 consonant has already been used for the first place. And then for the last place, only left 1 way because the 2 consonants have been used for the first and the third place. Okay, and then the second one, the vowel. So there are 2 vowels, which means that there will be 2 ways to place the first vowel in the second place. And then the next vowel will be only left 1 way. Then after that, to find the number of ways, we multiply them together. And the answer is 12 ways. Or there's an alternative way, whereby, I'm going to draw 5 spaces. So still the same, C, V, C, V, C. So these 3 C's, these 3 consonants can be arranged in random order, which means that there will be 3 factorial ways to arrange the consonants. And then the V and the V, there will be 2 factorial ways. So the number of ways for this will be 2 factorial times with 3 factorial, which is also 12 ways. Okay, so both ways are accepted for exam. Okay, now let's look at B. Each arrangement begins and ends with a vowel. I'm going to draw 5 spaces, 1, 2, 3, 4, 5. So the first and the last one must be vowel, which means that the remaining 3 spaces will be for consonant. So this one, it will be in one group. Okay, so the V, for the first place, there will be 2 ways to arrange a V, and then the last place will be 1 way. And then the C's in the middle, these 3 C's, can be arranged in random order. So it will be 3 factorial ways. So the number of ways will be 2 times 3 factorial times 1, which is equals to 12 ways. Or we can also use another alternative way whereby I'm going to draw 5 spaces, and then we have the V at the beginning and V at the end, and then C, C, C. Consonant, consonant, consonant. So these 2 V's can be arranged in 2 factorial ways, whereas these C's, will be 3 factorial ways. So therefore, the number of ways will be 2 factorial times 3 factorial, which is equals to 12 ways. So either way can be used for exam. Let's look at C. The consonants and the vowels are in their respective groups, which means that we're going to group the C's together and the V's together. So for this, C in random order, here will be 5 spaces. So here will be 3 factorial ways, and this will be 2 factorial ways. And also we can interchange them, whereby I'm going to put V first, the 2 V's, and then only the 3 C's. Which means that later I'm going to times 2. So the number of ways will be 3 factorial times 2 factorial, and the answer times 2. Therefore, the final answer is 24 ways. So that's the answer. Let's look at question number 2. Find the number of ways for 4-digit numbers greater than 2000 to be formed by using the digits 0, 2, 4, 5, 6, and 7 with repetition. So here we have 6 digits. And we have to form a 4-digit numbers, which means that it's 1, 2, 3, and 4. Greater than 2000, which means that the first place has to be either 2, 4, 5, 6, or 7. Which means that the number of ways to arrange for the first place will be 5P1. And then the remaining 3 spaces will be, since there are 6 digits given, so 1 digit has already been taken for the first place, which means that left only 5. And then there are 3 spaces here, which means it's 5P3. And then we times together, the answer is 300 ways. Let's look at question number 3. Find all the possible arrangements of using all the letters in the word trigonometry if G is the first letter and E is the last letter. So first I'm going to count trigonometry has how many letters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 letters here, which means that I'm going to draw 12 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and then they say that G is the first letter and E is the last letter. So for the first one, it will be 1P one way, and the last space will be 1P1 as well. And then here, there's a remaining of 10 spaces. So it will be 10 factorial, and then there's a repeat of, let's look at the word trigonometry again. Okay, here we have 2 I's, which are repeated, and then we have 2 O, we have 2 R, and we have 2 T, which means that we have to be divided by 2 factorial times 2 factorial times 2 factorial and times 2 factorial. Okay, and then we times them together. Okay, so the working is 1P1 times with 10 factorial over 2 factorial, 2 factorial, 2 factorial, 2 factorial times with 1P1, which is equals to 226,800 ways. And this is the answer. Let's look at question number 4. A family consisting of a father, mother, and 4 children are seated at a round table. So the keyword here is round table. So we know that there's a formula that we need to remember. It's n-1 whole thing factorial, remember? Okay, find a number of different ways that can be seated if there are no conditions. Okay, so let's solve for A. No conditions means that the number of ways will be n-1 whole thing factorial. Okay, so here how many people? Father, mother, and 4 children. So 1, 2, then plus 4 will be 6 people. So n is 6. Okay, which means that I'm going to substitute 6 here. So 6 minus 1 whole thing factorial. And it's equals to 5 factorial. And the answer is 120 ways. Okay, now let's solve for B. The father and the mother are seated together at the round table. Okay, let me draw one round table. So let's say this is a round table. Okay, round table. And then the father and mother has to be seated together. Let's say this is the father and this is the mother. Okay, and then the other 4 children will be in random order. Okay, let's say C, 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 C. It can be C1, C2, C3, C4. It can be C2, C3, C4, C1. Okay, and so on. Okay, but the condition is that the father and mother must be together. Okay, so here this is considered as 1. Okay, they are considered as 1. So 1 and then 2. Okay, here 1, 2, 3, 4, 5. Now my n is considered as 5. Okay, so which is 5 minus 1 whole thing factorial. And then for this one, father, mother, it can be also mother then father. Okay, so therefore it will be 2 factorial ways. So which means that we have to times 2 factorial. Okay, n is equals to 4 factorial times 2 factorial. And the answer is 48 ways.